This is going to be a solution to the second example in the lesson on the magnetic force on moving charged particles. And the question there is, you have the example of an electron moving in Earth's magnetic field. And we're given what the strength of Earth's magnetic field is, 5 times 10 to the minus 5 Tesla. And we're told that the electron has an energy of 1 kilo electron volt. What is an electron volt? I'll get to that a little bit later. But we have two parts of the question. One is the maximum force of the magnetic field that it exercises on the electron. And the second is, how does that compare to the force of gravity? So let's get back to this unit of the electron volt. And we're given the electron has an energy of 1 kilo electron volt, so 1,000 electron volts. What is an electron volt? So 1 electron volt, it's a unit of energy. It is the energy that is acquired by an electron when it moves through a potential difference of plus 1 volt. So here we have a diagram of an electric field, parallel in this case, and we have a potential here. So the potential decreases to the right as in the direction of the electric field, and the electron is moving against the electric field because it's negatively charged. So then let's get an expression for the energy that is acquired by the electron in moving through this potential difference of 1 volt. So then we know that the energy acquired is going to be minus Q delta V. So this is now minus Q times 1 volt. So then Q is the elementary charge, so this is going to be, and because we have an electron, the charge is negative, so this is now minus 1.60 times 10 to the minus 19 coulombs times 1 volt. So then this is minus signs cancel out, so this is now 1.60 times 10 to the minus 19 coulomb times volt, which is actually joule. So this is 1 electron volt. This is 1 electron volt, and it's a unit of energy, and is very handy when we're dealing with elementary particles like electrons and protons. So let's go back to our question. What is the maximum force that the electron can experience in the magnetic field of the Earth? So we know that our expression for the magnetic force is Q V cross B. And we're given what the magnetic field is here. So this is the magnetic field of the Earth. We know that this is going to be maximum when the cross product is, when the vectors are at 90 degrees to each other. So the sine of the angle is 1, sine of 90. So then if we're talking about the magnitude and the maximum of this magnetic force in absolute magnitude, this is just going to be Q V times the magnetic field strength of the Earth. So now we have to figure out what the velocity of this electron is. And we're given what the energy is. So this is the kinetic energy. So then the velocity is just going to be obtained from the kinetic energy. So half MeV squared is the kinetic energy of the electron. So then the velocity of the electron is going to be the square root of 2 times the energy over the mass of the electron. So this is our expression for the velocity of the electron. So then we put this in here, so then we get the maximum force. I'm just going to write that as max FB is going to be QBE times the square root of twice the energy of the electron over the mass of the electron. So now this is going to be, and since we're just talking about the magnitude of the force, I'm going to take this charge as a positive. So this is going to be 1.6 times 10 to the minus 19 coulombs, the charge, times the magnetic field, which is 5 times 10 to the minus 5 Tesla, minus 5 Tesla. Clearly I'm going to have to go on the next line here, times square root of twice times 1,000 electron volts, 2 times 1,000 times an electron volt, times 10 to the minus 19 joules, over the mass of the electron, which is going to be 9.1 times 10 to the minus 31 kilograms. All right, so this is this times this times this. There's no division here happening. So I'm going to steal some space under my definition of the electron volt here. So then this is going to be the maximum magnetic force evaluates to, after all these numbers are taken into account, I have calculated this to be 4.5 times 10 to the minus 6 newtons. And so again, we have to do a unit check to be sure that this is newtons, but this here is units of velocity, as we know, so this is actually meters per second. And we have coulombs and Tesla here. The Tesla is a Newton per annum meter. When you actually do the unit check, you'll figure out that this does evaluate to newtons. So this is our answer to part A. This is the maximum force that the electron can experience in Earth's magnetic field. The force can be less, of course, if the cross product is such that the two vectors, the velocity and the magnetic field vector, are not at 90 degrees to each other. How does this compare to the force of gravity is our second part. So this is max FB. What is our force of gravity? I'm just going to steal another corner here. Force of gravity is going to be the mass of the electron times the acceleration due to gravity. So this is 9.1 times 10 to the minus 31 kilograms times 9.81 meters per second squared. So this evaluates to, and I've done this calculation too, so this evaluates to 8.9 times 10 to the minus 30 newtons. So this is our force of gravity on the electron.